All right, welcome everybody, wherever your time of day you're at, whether good morning, good afternoon, good evening from around the world. Thanks for joining us today for our webinar with GitLab, Innovate Faster Without Sacrificing Security or Quality. We're very stoked and excited to have Victor and Brian from GitLab with us. My name is Luke Tucker. I am the Director of Content Strategy at HackerOne. All right, we can go to the next slide. Cool, so just before we get started, a few housekeeping items. We want to make this webinar lively and interactive, so be sure and ask some questions, and you can do that in the question box on the right-hand side in GoToWebinar. You see that box there. Make sure and ask questions throughout the webinar. If we have some good ones or some time, we'll maybe keep it interactive and ask those, and I got some of my own queued up as well for Victor and Brian. All right, next slide. Okay, so I wanted to just talk real briefly about HackerOne, and then we're going to hand it off to Victor to get rolling with the main presentation today. So as you can see on the screen, HackerOne is the world's #1 bug bounty and vulnerability disclosure platform. So in fact, we've actually solved or fixed from our community more than 45,000 vulnerabilities. I just checked it today. We reached that milestone, which is very exciting. And we've actually paid out hackers over $17 million in bounties. So very exciting. Next slide. So what do we do? Well, imagine on one side we have all these amazing companies, and the other side these incredible hackers. We're kind of that middleman that connects them so that the vulnerabilities they find, because there's no such thing as perfect software. The researchers have a great platform and medium to report that to the companies. Companies have an amazing automated workflow and platform, which we'll kind of describe a little bit on the next slide. Next slide. All right, so how does HackerOne work? This is kind of one simple graphic. It's much more than that, but we provide all the tools you're going to need to communicate with the hacker. Hackers consistently say that one of the most important things that matters to them from a company standpoint is their responsiveness and communication. They show them that respect. So from your side, whether it's receiving a vulnerability from a researcher or soliciting for more bugs via cash incentives with the bug bounty program, HackerOne is the platform that provides the tooling, the analytics, the best practices automation, the white glove service, triage will work together to ship the fix and reward the hacker. Next slide. So who works with us? Well, we actually have over 800 customers. You see some listed here. Slack, General Motors, Twitter, Starbucks, Dropbox, Nintendo, Adobe, Uber, Salesforce, Snapchat, Lufthansa, Intel, and over 800 others. We've actually even worked with the Department of Defense. US Air Force is launching very soon, and we just did the US Army earlier this year. Next slide. So I did want to do one quick teaser for a fresh newsletter we write every single day. If you're interested in application security or hacking information or bug bounties, this is the newsletter for you. We make it fun and entertaining, quick sound bites of info on a daily basis. And we like to say it's an AppSec newsletter that Kevin Flynn from John would read as well. So I am very excited to be able to introduce Victor. Victor is the product lead at GitLab, and then Brian will be coming in to the presentation later. So Victor, welcome. Thank you so much for being here. Take it away.
Thanks. So my name is Victor Wu. I'm a product manager here at GitLab. We have plenty of product managers, so you're just going to be stuck with me today. So we're going to really go quickly through this presentation. We're going to start off with just a quick intro of what GitLab is, as you see on your screen, and we're going to talk a little bit about how some of the best practices for developing software in the context of security, and then we'll wrap it up with Brian, our security lead here at GitLab, talking about how we leverage HackerOne, some use cases or case studies, and we'll wrap it up with some questions. So you might have heard of GitLab. Who are we? What do we do? So in sum, GitLab is an integrated product for the entire software development lifecycle. So you might have heard of GitHub, and indeed GitLab is similar to GitHub, but we are an open source alternative to GitHub. And instead of focusing on open source projects, as GitHub has done, we've moved quickly into the enterprise space. So interestingly, 2/3 of organizations that are already using some Git solution on-premise are actually using GitLab. So we have plenty of customers, and we're very excited about that. And we're not just a source control platform, even though we do very well in that space. We're a complete platform, so everything from issue management to planning. So as you see on the screen, from chat integration, issue boards. So whether that's an agile board or whatever it's called in the various tools, we have that. We have, of course, source code management with Git. We have an integrated source control, a collaboration platform, not unlike GitHub. And then we also have later, down the software development lifecycle, we have integration with CI/CD, our own in-house version inside GitLab, and we integrate with other tools. And then we're building out tools to deploy to environments and monitoring those environments, so on and so forth. So our sales pitch, our value prop is one integrated platform. You install one application and you get all these features, whereas with other competing tools, you might need to install 7 separate tools. Last time we counted. You need system admins to integrate them together. You might have different user interfaces, training, and so on and so forth, whereas we ship the entire thing in one package, one experience. So that's our value prop, and we're fairly unique in that way. So enough with the sales pitch. Let's move on to the next slide and chat more specifically about security within the context of software development. So what we're arguing here is that we can have security. We don't have to sacrifice security. I know software development is already very difficult. You have deadlines. You have your CEO, your CTO, your business manager saying, I want this feature 2 weeks ago, why isn't it here already? And now on top of that, we're Victor is saying that, oh, we can have security too. So is it really possible? And I think it is. So in our next slide, again, I wanted to hammer home that it's not. I realize that it's very difficult, and even before we talk about security, many folks in the industry, I'm sure many folks on the call have complained about similar things as you see on the slide. To meet a deadline, what are the reasons that we're shipping code before it's actually ready? So you see, if you squint at the slide a little bit, sorry, it's a little bit small, but often managers will say, we must hit a deadline. We have to ship this. We have to get this out. We promised our customers or our competitors will release a competing feature or product. We have to get it out. So we have to. Or maybe there's budget cuts, team turnover, or maybe if you see the 4th bar in that chart, it says unable to fix issues or bugs properly. So oftentimes I've experienced it myself in certain organizations. You just don't know what you're coding because it's so complex, and you can't fix a bug, and you just ship it, or you just gloss over it, or maybe you code around it. So there's many reasons why we are shipping code before it's actually ready. And today in this webinar, we're going to say that not only can you move away from that culture, you should also have a security mindset as well. So getting into details with the next slide, basically what we're saying is that we want to ship in small pieces, right? So you've probably seen this often, whether it's in an agile context, Scrum, or moving away from the so-called traditional waterfall requirements. We want to ship in small pieces so we can react more quickly, minimize risk, and so forth. So what does that mean in the context of security? Essentially, what we want to say is we want to take security and put it as a first-class citizen. So that's the last point on the slide here. You see security as a first-class citizen stakeholder. You want security controls baked in each stage of your development process. What does that mean? So when we develop software and we develop it in small chunks, we always say, we want cross-functional collaboration. We want people at the table earlier on, and when we ship a small feature, we can iterate on it, we can get feedback from our customers. So oftentimes that means that, let's get our UX folks early on, let's get our business managers involved early on. Let's not wait until very late in the game before we bring our UX folks, our product managers, or our senior engineers, architects. Let's bring security earlier on to the table and make sure they're recognized as first-class citizens. So whether that is an individual or it could be just a role for a person, maybe a senior engineer plays multiple roles. Maybe he has multiple hats. He's a security expert. He's also an architecture expert. Maybe you're in a small startup and your CTO plays all those roles in addition to being, a developer. He's also the chief architect. He's also the security lead. He's also the, the database guru. So whatever that means, we just want to get security as a first-class citizen early on in the process. So moving on to the next slide, how does that shake out in the actual development lifecycle? So again, a couple of examples here. Again, to the next slide, thanks. We want security when developers are already writing code. So so oftentimes this, if you have senior engineers, it's not a problem, right? Because you have, say you're a small startup or maybe a medium-sized company, you already have maybe a handful of engineers to kickstart your startup, or maybe you have senior engineer that's lead of your engineering team in a larger organization. So they probably have some experience, they know security best practices. So it's about maybe checking off the checkbox. Your senior engineer says, this is great. This line of code will prevent SQL injection, JavaScript injection. It's very good. It'll prevent that. So that's fine if you have those engineers. But what if you don't have those engineers? What if you have you're a very, very small startup and maybe you're just trying to get an application off the ground? So then you're probably using existing code frameworks. You're probably not reinventing things from scratch. And that's totally fine, and that's good. So if you're using, like GitLab, we use Ruby, and then we use some modern front-end frameworks, and then we connect to, Postgres and MySQL. So, these are off-the-shelf technologies, and those are great because you're building on the shoulders of giants. And if there's a security vulnerabilities in those frameworks, those will get fixed, and you can be sure that they're fixed, and you can use them, and everything is good. But things start to get tricky when, as your organization scales, or maybe your business value prop is that you're developing a very specific feature that you need to code around, and maybe a code framework. Maybe you're not doing basic CRUD operations in your business. Maybe you're doing something more fancy that the latest code technology frameworks do not support. So you need to talk to your database directly. You need to write some networking code. You need to write some really basic JavaScript, and you're not using a JavaScript library. So in those cases, you need to be very careful, right? So do you have, are you testing, are you accounting for all those security vulnerabilities? Are you for everything, for all those code libraries there, like Ruby and Java and the plethora of JavaScript libraries? They all have best practices and ways to make sure you're not coding security bugs when you're developing your software. So if you're doing those things from scratch, you have to be very careful. And as a developer, it starts there. So that's all about expertise and resources. So from a development perspective, you need to be very careful. And it really depends on your business. So if you're if you're a small business, maybe you can't afford that, and you have to be very careful. So are you able as a startup to play in this space, or do you need to hire those more expensive resources, a senior engineer, a security expert, if you're gonna be a startup that plays maybe, so say you're in the financial space and then you're playing around with sensitive customer data, dollars and cents, then your investment is going to be a little higher upfront. But maybe you're in another industry where maybe you're playing with less data, or maybe you can get by with not dotting all the I's and crossing all the T's. So it really depends on your business and your resources and expertise. And finally, from a systems and data perspective, again, when I chatted earlier about getting the right stakeholders, who are those stakeholders? They might be your your engineers. They could be your enterprise architect. It could be your operations team. It could be your business team. There's a lot more to your business than just writing code. And so if your operations team and you're working in a large organization, and then say, for example, your operations team will take customer calls, and then you have a security policy or an operational policy that says, oh, you cannot reset a password over the phone, or you need to send a physical snail mail to send a PIN. Will my new security feature, my password reset feature, change that operational policy? Is it compatible? You want those stakeholders early on in the process as you're developing the feature, whether you're conceptualizing the feature, writing the code, talking about the initial POCs, and so forth. You want those stakeholders early on. So yeah, in a nutshell, that's pretty much from a stakeholder and getting everybody early on in the table perspective. It's very important that security plays a critical role as a first-class citizen. So often they are not. So often you develop the feature, you're excited, and it's at the end, oh, how can we patch this to make sure malicious users won't attack us? And we just assume that the engineers will solve it for us. We just assume that the code frameworks will account for it. Oftentimes we don't account for it, and that's very dangerous. So with the next slide, we get a little bit more into say some of the features of GitLab. By no means is this unique to GitLab. We don't claim to invent conversations and collaborations, but I think GitLab does it very well, I would argue. And essentially what we encourage from our product, and what we encourage teams to do from a development perspective, is just to talk early. So for GitLab, just giving you folks a little bit of insight into what we do. We're a totally remote company, and we're totally asynchronous. So we don't work next to each other. We're not co-located. We can't look over each other's shoulder. So that forces us to be very good at writing things down, putting all our conversations inside the tool itself. So what we do is we encourage our developers to create what we call merge requests early on, even though it is not a complete set of code yet. So as you can see here, the example is that we create a merge request, we put in some code, maybe it's some POC code, maybe it's literally just one line that says, to do. And then the advantage of that is that then you can ping maybe your boss, or maybe you can ping a peer, maybe ping a product manager, or maybe say, UX designer, can you take a look at this feature that I just put together really quickly? What do you see? And then at the same time, you probably want to say, a senior engineer would say, oh, maybe there's this security vulnerability that you didn't account for by presenting the feature in this particular fashion. So again, what we talked about, getting the security stakeholders early on in the process, tools such as GitLab and many good tools on the market will allow you to have that conversation earlier. And what we want to encourage is not just have whiteboarding conversations, which are great, but also have the conversation in code, because ultimately that is what is shipped. And so an example here with what we call work in progress merge request, we can have the conversation in the context of code very early on. Next slide, please. So what we have here is just expanding on that fact of having that conversation. So depending on your organization, maybe just a informal conversation is enough. Maybe there's a little bit more audit and change control process that's needed. I'm not saying that's bad or good, but I'm just saying that some organizations that's more important, that you have maybe some stage gating where you have an approvals process where you say you need to sign off on this requirement, and a particular requirement you need a security person to review all the requirements and so on and so forth. So that's what we have in GitLab. We have it at the merge request level, and we're going to expand out to other places in the product where we can essentially have start introducing stage gates. So again, I want to encourage everybody that these are tools and you should use them according to your custom workflows and your needs. So some folks might cringe and say, oh, Victor, are you suggesting that you need to do hardcore strict waterfall where you need all these skates? Agile has told us that that's not necessary anymore. I'm not saying that. I'm saying whatever your organization is doing, how it runs your organization. It's not just about shipping code, but how your organization develops features, how you review work, how fast you move, what type of risk you adopt in your velocity of releasing features, how risk averse you are in your organization. We should respect that, because that's ultimately how you want to run your business and reflects of also how you compete in your particular industry. But also in terms of us developing GitLab, we want to develop a tool that gives you that flexibility. If you want to use some approvals process where you need to have every merge request approved by a particular role, or even approved by a particular individual who is an expert in security, then we give you the tools to do so. Let's go to the next slide. And then similarly, in addition to approvals perspective, for stage gating, we give you a little bit more controls inside GitLab for branches as well. So say you're developing a particular feature that is very sensitive, that maybe touches customer data, and it's extremely risky. Maybe we want to protect that branch and limit the permissions to it to maybe some senior engineers and so forth. Next slide. So getting to continuous integration, again, this is, again, not unique to security, but security dovetails very nicely within the context of continuous integration, and more broadly, continuous delivery or continuous deployment, depending on the buzzword or the context you're talking about. But essentially, the high level concept is that we want to work on small pieces of code and get them integrated into the mainline branch to minimize the risk of something not working or not being integrated. Or we also wanted to get it out to production as soon as we can, to minimize the risk of us not accounting for certain things, or our customers saying that's really dumb, and then why did you spend a whole month developing that feature? So what we really don't want to do when we're staring at the slide is say, is advocate for a product manager has spec'd out a particular feature, the developer takes the specs, goes into a cave, and codes on that feature for 2 weeks, emerges from the cave and shows it to his peers and product manager and says, ship it. We definitely do not want that. That's a very extreme case. I'm sure nobody on the call is doing anything like that. But I encourage folks on the call, and including myself and the folks at GitLab as engineers, that we should get to a point, or asymptotically approach to a point where we're developing code so quickly, or we're scoping our features so small, so that we can typically put up a merge request, say within a couple hours, or even at most within a day. So we can get something up and running within a day. So with continuous integration, you want your code to be up, you want it to be automatically deployed to typically a test environment, a UAT environment for business users to review. And so we want that as soon as possible. So in the context of security, there's a couple of things we can do. So I think that's in the next slide. Let's go to the next slide. So within the context of continuous integration, we typically may have a staging environment, a test environment. Sometimes we call it a pre-prod environment. Sometimes we call it a UAT environment. Essentially, it's any type of environment that allows you to validate your code, right? If you develop your code and it's just on a developer machine, and then you push it directly to production, obviously, there's no guarantee that will work. The point, obviously, of pushing it into increasingly production-like environments is to get your feature into a place that looks more and more like the real world, ultimately the production environment. So it's not very easy. It's very difficult. There's plenty of different webinars and technologies and tool sets that help with this, and GitLab has a lot of them, but that's for another webinar and a different day. But essentially, we want to get to a place where you can develop your code, push it into an environment, and it will look as production-like as possible, and also leverage automation to help you with that. So typically, you might push it into an integration environment, and it will run, say, a lot of integration tests. So for example, if this is not something that we do at GitLab, because we produce one piece of software and we ship it to our customers, but maybe you work in an organization where you are moving to a microservices architecture, and you have many different microservices or systems that are all hooked up together. And there's no way that you're going to work on something all at once. Typically, you work on a small piece of code that is only makes change to one particular microservice or subsystem, and you want to make sure that works with everything else, at least in your product area, if not in your entire organization or suite. And so typically you might have an integration environment where you release some code to that latest version of your microservice, and then the integration environment has a bunch of automated tests to make sure that microservice plays nicely with all the other services. And then there's all these things you need to sync up with data. Maybe you need to take production-like data, and then maybe you need to take production data itself, anonymize it, and then stick it into your staging environment or your test environment, and make sure all your tests are run not just against that latest code, but against production-like data, which is that anonymized production data itself. So there's a lot of technology and a lot of work involved here, but you can see how this dovetails or aligns nicely with security. With security, you might have certain tools to scan dynamically and inject, attacks into your systems, whether that be directly into your data, into your code base, do some automated attacks into your various environments. And in the same way that you have human users or business users who are doing manual testing in addition to the automated testing, you might have human users who are doing the security testing as well. So again, if you are developing those features in small chunks, if you're involving the stakeholders earlier on into those environments, that they can jump into those environments and start playing around with the feature, whether those are business users who are playing with a new feature, whether that is a senior engineer, maybe that's a security lead that has a checklist that they go through as they run through features. It's very important to get those features into those environments early as you can, so to get people seeing them. And then sometimes this could be automated, sometimes it could be manual. Often in organizations, you have maybe you have an army of QA engineers who are just running scripts, whether those be automated, manual, or a combination of both. Maybe they're also running security scripts as well. So I think that's the last. Yep, that's so. Let me wrap it up here. So that's essentially what we do in terms of, or in terms of what we're promoting at GitLab in terms of, account for security early on, accounting for security as a first-class citizen stakeholder. But let me throw it to Brian, as he's going to tell us a little bit more how practical things of how we use GitLab and HackerOne.
Thanks, Victor. This is Brian Neel. I'm the security lead here at GitLab. When HackerOne and GitLab got together to plan this webinar, somebody proposed the question, why does GitLab use bug bounties? And to me, the answer seemed fairly obvious. And then I tried to put it into words, and it was a lot more difficult than I thought. So if you go to the next slide, this is a security engineer's viewpoint of the development process and how it's evolved. This is for maybe an enterprise web application, not really for a, if you're launching rockets into space or something, you're probably using something a little more complex than this. But I think this is what most of us deal with day to day. So early on, I think maybe the late 90s, early 2000s, security was an afterthought for the most part when you're developing an application. On the left side of the graph, you see the idea, whether management or a developer comes up with an idea and then starts planning and user requirements and coding, and then they get to version 1 in the middle and version 2 on the right-hand side. Early on, developers might have been left in charge of security completely. It was up to them to decide how to do things the proper way when it came to security, to do the security audits if they were done at all. If you could click again on the animation. So at some point, I think companies realized that they were getting a lot of security reports. It's making them look bad. Before code was released to the public, it needed to go through a security audit. So they may have come near the end of the development cycle to a developer and say, look, you need to send this to the security team. They need to go through it to make sure you're doing things properly so that we don't get any security reports after it goes out. If you were lucky enough to have a security team, then they might go through it. And of course, their time was limited as well. They might have looked at, do you encrypt passwords? Do you use SSL? Do you do you keep a password history, or do you have a minimum password length? Very simple stuff, at least back then. And as you can see, this is a one-time thing. I mean, before you release, it's squeezed in. You hope you have enough time to fix any vulnerabilities that were identified during the audit, and then you release the code. Click again. So then vulnerability scans came along, and they were useful for certain things, network vulnerability scans primarily. The vulnerability scans were usually the purview of the security team again, so they got run against the whole network when the security team decided to run them. Developers really didn't have much input into this process, and if they saw it at all, it was a list of vulnerabilities that were probably chock full of false positives against their application, and they were expected to justify either why it wasn't a vulnerability or provide a patch on demand to the security team. Click again. And then, professional penetration testing groups came along. I was a part of one in the late 90s. This was one of the first red teams. Typically very expensive, typically expected to have a very wide breadth of experience with different technologies, mostly because of the cost and the time involved. You might be lucky to have a penetration test run once a year. So obviously, you can see there's still huge gaps in the development process where security isn't really being considered at all. Click again. So sometime after these vulnerabilities started to pop up, people noticed that there were common themes with the vulnerabilities, and the best way to prevent these from being reintroduced was to train developers to avoid them. I mean, this is also something that only happens occasionally. It's fairly expensive. It's time consuming for the developers who have other things to do. It might be at a very high level. I mean, the training that I've typically seen would be, well, let's teach the developers how not to introduce SQL injection. Let's use parameterized queries, or let's teach them how to encode HTML. And then that's it. It's a one-day training or a one-week training, and they're sent off. And the trainers may not have a lot of experience with the technology stack that the developers are using. So there's still a lot of gaps involved, and it's a very occasional thing. Next, yeah. Static analysis tools became popular at some point. Again, they were useful for a limited subset of vulnerabilities. If you're looking for remote command execution, it might pick up stuff like that. SQL injection, it might pick up certain types of things like that. Again, it was something that you ran right before a release, and then you had to deal with whatever findings it had. They're chock full of false positives, of course, especially back then. Click again. But at some point, when continuous integration came along, people realized the static analysis tool could be included with continuous integration. Every time someone merges a branch into master, you can review that with static analysis tools to look for vulnerabilities. One of the problems they noticed probably right away was that static analysis tools are going to have a lot of false positives, and the last thing you want is developers to be blocked from merging code because the static analysis tool says something is vulnerable. So what happened in a lot of cases is static analysis tools are kind of tuned down so that they only trigger on the most egregious vulnerabilities. You don't want to block a developer's workflow for something that turns out to be a false positive. The next step, of course, around the same time was dynamic analysis tools, web application scanners, database scanners, and things like that. Again, because they're complicated, they tend to be owned by the security team. They tend to be a checkbox at the very end of the development process. And due to the false positives, the developers end up wasting a lot of time trying to figure out, first of all, what usually is a very brief summary of a vulnerability that's hard to interpret, what it means, how it impacts the application. Is it a vulnerability for our application, or is it just something that is a vulnerability for 1% of the users out there, 1% of the developers out there? Next. And test-driven development, which I'm a big fan of, which provides a lot of benefits to the development process, it came along, and it allows the author of code who understands the authorization process the best to write tests before the code is even introduced, to say exactly how the application should function, what users should be able to access, what endpoints, and what they should be able to do. And this is great. There's no one better than the author of the code to figure this sort of thing out, and it can be verified every time there's new code pushed to the project. The problem comes along when that code gets changed. That same developer may not be the one who changes it. The person who changes it may make a mistake, may not include new checks for new endpoints, and you leave a lot of vulnerabilities open. Unless that original author is going back and reviewing every single merge, then it's not going to be comprehensive. The great thing about it, of course, is it gets run every single time. If you're using a product like GitLab, it gets run every single time you push new code. Next. So as you can see, there's still a lot of gaps in the development process. Where bug bounties come in, at least for us, is right before you, or right around the time you push a beta out to customers, you can open up a bug bounty program, and it provides sort of an endless coverage from prior to version 1 all the way through version 2 and into the future for any new vulnerabilities, anything introduced in new libraries that are included, new authentication protocols, new features. You know that you're constantly going to have professional hackers out there testing this code against new types of vulnerabilities. Next slide. So I wanted to provide a couple examples of how we've benefited specifically from HackerOne's bug bounty program. So next slide. This report came from a researcher who issues a lot of reports to us. Some of the things I love about this are, you know, there's a brief summary of the vulnerability provided at the top, which allows us to immediately identify if it's a critical vulnerability or not. In this case, it was. There's a proof of concept included next. Of course, one of the things I love about this proof of concept is it does not use our production network to demonstrate the vulnerability, which is always a plus for the researcher. There's a listing of the vulnerable code, which is another great aspect of this. I mean, if you're used to the old-fashioned bug reporting, someone sends you an email, I found this vulnerability, the odds of them identifying a line in your code where the vulnerability exists are next to none. And if you ask them for more information, good luck getting it. HackerOne provides us with reassurances as to the quality of the report and opens a line of communication between us and the researchers so that we make sure that we have all the information we need. And of course, at the end, there's a proposed fix here. Now, this proposed fix is, well, don't do what you're doing, which was helpful in this case because what we were doing was wrong. In this case, the vulnerability was in a method called public send, which probably shouldn't be a part of any application that's exposed to user input. But the vulnerability itself was, excuse me, it's a method that allows the code to call another method based on name. It's passing the parameter to the public send request. So because we were allowing user input as a parameter to public send, that user could execute any method by name that existed in the object that was being called. In this case, the only methods available that were dangerous were delete or destroy all, which, you know, is nice, except that it allowed the researcher to delete all issues that existed in a GitLab instance, which is obviously not something we want. So we treated this as a critical vulnerability. It looks like it was disclosed, or it was announced on November 28th. It was reported to us, and our normal disclosure process is 5 days. So we had a patch ready that day, and we announced to the public we were going to have a critical security release 5 days later, so that they have time to plan downtime. And 5 days later, our release went out. There's several reasons why this particular vulnerability slipped through our normal security development lifecycle. In particular, static analysis tools do not look for a method like this. They seem to be unaware of these dangerous methods in Rails that are provided by Rails. Outside developer training doesn't cover something this specific typically. Our dynamic testing does not look for this type of vulnerability. I mean, if you use a tool like Arachne or something, it doesn't typically try to pass method names as symbols and parameters to see if there's an object on the other end that will respond to it. So it would be very hard to pick up with dynamic testing. Now, it would have been picked up, we hope, if we had done a black box or a white box test during the window where this vulnerability was exposed. But this vulnerability happened to be exposed, I think, for a matter of weeks. It was only around from, I think, version 8.17 to version, or 8.14 to 8.17. So 3 months at most. The odds of us doing a white box test in 3 months, you know, are 25% if we do one every year. And obviously the developer wasn't aware that this was something to worry about. It was a standard method that apparently they had been using for a while, and they just didn't know that passing user input to the method would be dangerous. Next slide. Yeah, and this next one I like, not because it was a complicated finding. I think it was fairly typical, next slide, of the type of reports that we get. It's fairly obvious when you look at it, and you can see that by the length of the report. the researcher, we happen to release a new feature in GitLab 9.0 called subgroups, which is just groups inside groups. It was released on March 22nd. This researcher identified the vulnerability and reported it to us that same day. I think it was 3 or 4 hours after our code went live. It's a complicated vulnerability in the sense that it's complicated to check for. Any sort of dynamic or static analysis tool is not going to pick this up. It could have been picked up by tests written by the author of the feature. However, it was such a complicated feature that the tests end up being, hundreds of checks each, and this one was missed. So I think, the odds of someone finding a vulnerability like this in the code the day of release, if you don't run a bug bounty program, are fairly small. If you get lucky, maybe one of your users are looking through all of your change code for every release and they find it. But I think HackerOne in particular provides a real incentive for people to examine the code immediately upon release, because there's no better time to find a new vulnerability when the code is just introduced. Next slide. So I think, Luke, if you want to take over and summarize, or Victor?
Yep.
Yeah, that's been amazing, guys. Victor, did you want to kind of recap some of these notes you got here?
Yeah, no, just very quickly, just wrapping up, we want to let everybody know, please ship secure code. That's very important, as we've discussed at length. But more importantly, how can you adopt the culture, the tools, the processes to help you do that? Today we talked about just some of the tools that we're using day to day and some of the processes we do, whether that's using GitLab or HackerOne. And also the best practice of shipping small iterative changes, doing it often so it doesn't get stale, continuously integrate that code, and of course finally, as Brian just explained to us, just leveraging the community to quickly and use tools like HackerOne to find those vulnerabilities and communicate those back to the software vendor. Luke?
Awesome, guys. Such good stuff. I had some questions throughout, but you guys are just on such a roll. I figured we just let it ride, and we'll kind of have some time for Q&A now. You can actually go to the last slide. I think it just says Q&A, and we'll have contact info there, or your wonderful photos there. So, guys, anybody listening online, feel free to ask your questions in the question box on the right. I'm going to kick it off because I got some questions I've had and wanted to kind of just roll with that. So, kind of going back, Victor, to one of the kind of middle part of your presentation, you were talking about, I think it was slide 12, you said security controls are baked into each stage of your development process, right? And we were kind of talking about giving security a seat at the table. I think your term was, making them a first-class citizen, so to speak. So just my question for you, I guess, is maybe if you could even elaborate on that a little bit, or what does that look like specifically at GitLab? Is it like, okay, we have this meeting, or you have a merge request and there's a comment, so a security stakeholder like Brian's gonna pop in. How do you kind of handle that? What are some of the things you guys do?
Yep, thanks for the question. That's great. So within the tooling currently within GitLab, we have approvals. We have the ability to use certain groups or individuals, so you can specify a group within GitLab, the tool, to say that this is the security group, and with every merge request you have to have at least one approver from that group. So that's something within the tool. Within GitLab, the organization, how we do development. I'll let Brian finish off in a second on what he does day to day, but within the sort of the development organization, or who I work with day to day as a product manager, we really heavily rely on our engineers. So I can say, for example, right now we're not hiring junior engineers. We're not hiring people out from college, because we just can't afford that right now. We're not that scale of an organization yet. So we're hiring fairly experienced engineers, and one of their requirements is just having that experience in particular during code review. So typically, any engineer, whether they're more senior or junior, will work on a feature, and during the code review process, we have a more senior person review it. Typically, anybody can review it, and oftentimes they do, but we have specified people, what we call maintainers, aka end bosses in the past, who are experts in a particular area of GitLab. And so in addition to good code quality, security is something under their purview as well. Brian, I didn't know if you wanted to jump in on anything particular that you do day to day or your team does day to day.
Yeah, I mean, I think you hit on some of the big things. For me, a tool like GitLab benefits me a lot because I get hit several times a day. I get tagged in issues that are just ideas. If somebody wants to introduce a feature, somebody wants to add support for authentication protocol, or somebody wants to do something related to security better, and they tag me in it, and I get a chance to go review it before any code has been written. And then in addition, like you said, with the merge requests, I mean, anytime something that hits on security is produced, I get tagged in a merge request or someone from the security team, and they review it and make sure that it meets all the basic standards. They can run it through their own static analysis tools or dynamic analysis tools at the time, and then they give the thumbs up, and it goes through the normal, back end or front end review process to make sure that it meets our coding standards and stuff. But it makes my life a lot easier because I'm not dealing with security only at the end of the development cycle.
Yeah, that's interesting to to see how that kind of dynamic, even just from the idea stage. Thinking of your graph, right? You had that, but actually on it, you're kind of in that idea stage before they write too many lines of code. So that's great to have your input there. We actually got a question coming in from Lauren. So let me just read her question here. So will cybersecurity researchers at HackerOne, identify bugs in individual developers' code, or will they only look at or search for bugs in GitLab releases?
Well, there's nothing preventing anyone from looking at any branch of the GitLab source code. I mean, it's all open source. If they wanted to identify vulnerabilities there, they'd be more than free to, and we'd appreciate it, just to make sure that if that branch gets merged into the production code, it doesn't contain vulnerabilities. But our bug bounty program specifically states the releases. But yeah, I mean, we'd welcome any criticism of any of the code in the GitLab code base.
Awesome. Now, I think this kind of just question came up. We were talking about some of these feedback loops, right? You have that developer training within, that life cycle. And are there things that you've even seen, or other companies that have in past lives that you've had, Brian, that it's like, oh, we're finding tons of this type of vulnerability, and are we? Is it a simple message back? Is there some other like every month the security team does a recap or the debrief based on what you found in all of your security efforts? Because the other aspect is it's not like a one and done. It's a both and. Like you're doing bug bounties, you're doing the vulnerability scans, you're doing these other things in kind of your security cocktail, right? So maybe what is the aspect of that training that there's a feedback loop? How do you guys kind of deal with that?
Yeah, I mean, the way we handle it, I mean, first off, if we get a report or a series of reports, which has happened, where somebody identifies a certain type of vulnerability that seems to be prevalent in certain portions of our code base, I mean, the first thing we do is, of course, establish all the lines of code that are vulnerable, and we write patches for them. The next thing we're going to do is we're going to write tests to make sure that those vulnerabilities aren't reintroduced. And we're going to add documentation to our developer guidelines, which are included with the application and the documentation, that teach developers, community contributors in particular, how to avoid reintroducing that type of vulnerability. For instance, I mean, we get cross-site scripting attacks or vulnerabilities reported fairly often, usually in new features. And so we have kind of a custom library of cross-site scripting tests in our Ruby specs that can be run against any fields that process user input. Every time a new vulnerability shows up, we take that sample code, the proof of concept, and add it to the library for cross-site scripting tests. So hopefully any future features that are added will have that run automatically.
Excellent. So we have actually a related kind of question in terms of how you guys work with the hacker community in terms of your work with HackerOne benefit the developer community. And we kind of maybe mentioned that, but that was just the question from the audience: is how will the relationship with GitLab and HackerOne benefit developers?
Well, it benefits developers in the sense that they I say this as a non-developer. It's easy. They learn what they're doing wrong, which is
true. We needed a developer on this call too, right? To
probably, yeah, counterpoint.
Balance it. Okay.
Yeah, crossfire style. Yeah, everybody makes mistakes, especially myself. And the developers make mistakes. There are checks in place, hopefully, to prevent it from making its way into production. But things do occasionally make their way into production, even when they get reviewed by 3 or 4 different people in the merge request process. So yeah, I mean, I did want to hit on, you mentioned I think the question mentioned how hackers benefit. I will say that one of the surprising things with HackerOne that I found was, I mean, it takes a long time to develop a security skill set for a security researcher. It's not something you're going to learn in a university. It's not something you learn when you take CISSP. It's hard work. And we do occasionally, while most of the reports we get through HackerOne are very professional and obviously very experienced people, we occasionally get novice researchers, and they may misunderstand a report. They may make a mistake. We can guide them through the process and give them kind of a professional environment where they can learn. They're free to ask us questions as well. If we say, no, this isn't a vulnerability because we mitigate it somewhere else, they can ask us how we do that and why and how it works, and I think it helps them learn a lot. And the end result is we end up with a lot more security researchers, and we end up with a lot more security checks on our applications.
That's really cool, and that's kind of a testament to how you guys, look at it that way. You're maintaining that dialogue and working from like you said, the most experienced hackers out there to others that are still getting a feel for things and able to help them in their development. So I think that's excellent. We actually had a question come in from Nita here, and kind of a specific one, but he's saying, how can we customize the type of approvals depending on the merge? And he gave an example. For certain merges, the internal security maven or champion could approve, versus maybe for others, there's an explicit approval from the AppSec team that would be warranted.
Correct. So we have currently, I mean, these are great feature ideas. And so if I'm not answering something, or if you think of something that's not covered, just a PSA, please create an issue on GitLab and we'll try to get it in, or feel free to develop a feature yourself. But to answer the question, we have what I described earlier at the project level and at the merge request level. So we have a setting to set approvers, the required number of approvers, and who are qualified approvers at the project level. And then when you create a merge request, the merge request author or anybody that has permissions to edit the merge request can override in one direction those settings. So you can specify more approvers and more approvals required, or more qualified approvers, but you can't go in the other direction. So that's just one way we allow a little bit more flexibility and configurability per merge request. And obviously we're working on more features in that direction at the instance level, changing things across groups and so on and so forth. So as we scale up and try to introduce our software to different organizations with different needs, we're going to take that and try to expand on the configurability of our approvals process. And again, it's just at the merge request level today, and we call them approvals because that's what they're often called in many tools. But we're experimenting on can we introduce it at the issues level? Can we introduce it essentially at the ideation stage? So what Brian mentioned, somebody pinged him and he gave a comment. At GitLab, we're fairly open. We don't have a lot of rigor and process from that perspective because we're still fairly small. Maybe in the future that will evolve, but I can imagine in some organizations where we have more of those stage-gated processes, even at the ideation stage when you're speccing out features and you're not writing code, you're just creating UML diagrams, for example. We want to be able to approve of those from a security perspective. We are definitely aware of those use cases and will slowly attack them one by one.
Gotcha. Well, I actually have a question I can say, and anybody on the line, Ed or Kalpesh or Karen or Michael, anybody, we got about 5 minutes with Brian and Victor, so if you have any questions, definitely send them our way and we'll try and get to them. But Brian, going back to that first report you showed, I know you kind of chuckled when you were saying who the researcher was, and I know why. And for full disclosure on our side, that's actually one of our co-founders, Jobert Adma, and he is a very active hacker. And true to many other hackers, actually, they have a certain number of customers or a certain number of, we would say, attack surfaces that they kind of hyper focus on. And obviously, he's a great hacker, great reporter. My question comes to, Well, it's a two-part question, I guess. We'll tee it up for you. So one is, I know he kind of put there that fix, and you mentioned how that was valuable in terms of going to the specific vulnerable lines of code and saying this is maybe the clear fix, what you need to do, don't do the public, whatever. But then maybe what's impressed you the most about the hacker community? So specifically when they're doing a report, is it great to have that fix in there? And the second part is maybe just kind of opine on what are some of the things in the community and HackerOne specifically that kind of impresses you?
Yeah, I mean, it's funny you mentioned that report because I mean, I did joke. I was tongue-in-cheek joking about his proposed fix, which is don't do this, which it sounds trite. I mean, it sounds like it's like he's trying to avoid putting work in, but in truth, I mean, that is the fix. That don't use public send, especially don't use it with user input, because I think you know, we weren't about to reuse that method, but I think a lot of people when they get a report, they look for the easiest fix, and the easiest fix in this case would have been filter the user input, make sure they don't call existing methods in that object. But that would have been the wrong way to do it, you know. So I mean, by saying don't use public send, we ended up going about it the right way and calling the methods we wanted to support directly instead. But yeah, I mean, to your larger question, I mean, I've been part of the hacker community for a long time, over 20 years now, and I've always been impressed by the skill sets involved. But one of the things I did notice about hackers is they tend to have an area of expertise. You know, back in my day, you know, you had people who were Unix experts, or you had router experts, you even had like phone experts, like some people we've all heard of. And when you have them all working on your application at the same time, it provides more complete coverage. I mean, excuse me, if you hire an external penetration testing group, they're going to be expected, like I mentioned before, to have a wide range of expertise, which means kind of normally it's shallow expertise, not very deep on any particular issue. But with hackers, it's different. I mean, they have their area of focus. We have people who only seem to ever report cross-site scripting vulnerabilities, and that's great. I mean, they have a huge library of potential exploits they use. But the thing that's really impressed me about hackers the most with regard to bug bounties is how they've embraced them, because I think in the early days, you know, hackers complained a lot about having security reports treated properly, professionally. They were being ignored. They needed an outlet, and a lot of people on the other side thought that was an excuse. They were just looking for an excuse to release a zero-day and get their name in the news. But when bug bounties really became popular and the program showed that it worked, hackers really embraced it, and they embraced responsible disclosure, as they said they always would. So I know when bug bounties first came out, and when I heard about them, I was skeptical, not because I thought it was a flawed process, but because I thought companies wouldn't pay. But that's been proven wrong again and again. And all these big companies, almost all of the big startups, use bug bounties and pay bounties all the time, and they find a tremendous value in it.
Yeah, and even just to kind of chime in on that, and Victor, I don't know if you have anything to add on that point, but just wanted to kind of make the comment that, you know, you were talking about the diversity of the researchers that are, you know, maybe on the more junior side that are also, you know, doing security effort on your, focused on your product, that they care enough, that they're investing time in theirs, as well as the maybe more senior individuals like Yobert that are providing, you know, in some ways, maybe even elegant reports that are coming from left field and things that, as you mentioned, these scans would never pick up. You know, when you look at the diversity of the community, you know, that kind of breadth and nature is just that at scale, something that you can't handle with a, I mean, 2 to 5 person team, right? In any way. But Victor, did you have any other thoughts kind of on that conversation point?
Nothing in particular, but it just reminds me of our company strategy as GitLab being open source, open core as a business model, and really relying on the community to push our product forward, because we are, you know, a funded startup, but we're not a publicly traded company. We have limited resources, and we rely on our community to develop our product and quote unquote to fill in the gaps. And so from a security perspective, that's definitely plays a huge role as we've talked about today. Excellent.
Well, we have come up on our 8 o'clock hour. I do have one last question for you guys. It should be a pretty quick one, probably directed at you, Brian. The question is, what are some of the, so talking about the security cocktail, okay? What are some of the tools that you use for automated testing? This is somebody's looking for some tips here.
Well, we're primarily Rails, although we do have Go and some other languages. For our automated testing, I mean, we use open vulnerability scanner for the network level stuff. And it, it does some application stuff as well with some custom checks for things that we've identified. And then we use primarily Arachni for our dynamic web scans for each release.
Fantastic.
Yeah, and there's static analysis, so there's custom stuff we've written that's integrated in our CI. And I think if you go to the GitLab website and look at our project and look at our CI files, you'll see some more tools.
Excellent. And that's actually my last point was just more of a high five to you guys and a kudos to your company. You guys do some amazing stuff with relation to transparency, and anybody online, if they actually want to see who has comment rights on HackerOne reports and a lot of other things, you can go their About Us page and you can kind of see what everybody does, who's a responder. Going back to what hackers really love is communicative and the respect that they get, and just kind of that open transparency. So kudos to you, Brian, Victor, and GitLab. We're huge fans of you guys. Thank you for joining us today. We're really, I must say for everybody listening, we are truly an international webinar today. I know, Brian, you guys are a completely distributed team. You're in different places. I'm across the Atlantic now, calling from Amsterdam. So just very excited to be able to have this conversation with you. Everybody on the line, we will be following up with the slides, with the recording, and all that jazz. Email us, sales at HackerOne, Luke at HackerOne. I know their contact info is online as well. Thank you very much. We're about 2 minutes over, so I want to be respectful of our time. Brian, Victor, thank you guys again. Appreciate it.
Thank you.
Yep, have a good one.